We're looking at finding expected value for discrete random variable. We looked at how we find that. We looked at how is it different from simple average. Now I want to look at finding expected value of a function of a discrete random variable. Of a function of a discrete random variable. Here, something that we need to keep in mind is a function of a function of a random variable. A function, so fn is a short for function. A function of a random variable is also a random. So if gx is a function of the random variable x, then gx is also a random variable, right? So this is something that we need to keep in mind. So now we say we have a function of a random variable, and since that's a random variable in itself, so we can find its expected values, right? Because we talked about how to find expected value for discrete random variable. We're saying what if we have a function of a random variable, which itself is a random variable, how do you find the expected value for that? So now we know, okay, we learned the expected value of x is, concisely we can write it like this, right? We learned this, we can write it like this, x pxx, right? Where here this represents each value the discrete random variable takes, and this is the corresponding probability x is x. So now expected value of gx. Now we know x is a random discrete random variable, so gx, which is a function, that is also a discrete random variable, right? So the way we're going to define, the way we're going to find expected value of this function random variable, which in itself is a random variable. Is now one thing is that because this is a random variable itself, right? If x is a random variable and gx is also a random variable. So just like x, we can use the PMF of g of x to find its expected value, right? We could have named this y and we could have said the expected value, this is this summation py, right? Because x is a random variable, gx is also a random variable. So we could have named it, say, y, and we could have said, okay, I can find the expected value of this random variable y, which is gx, by just using its PMF, just like I found for x. Because just like x, gx, which we named y, is also random variable. But the idea is that you don't have to do that. You don't need the PMF of this function of x to find its expected value. We can just simply find the expected value of a function of a discrete random variable using the PMF of that random variable itself. So this can just be written as x and, sorry, instead of x, we have g of x here, right? So the difference is over here. Right, so over here, because we were finding expected value of x, so we had x here. Over here, because we're finding the expected value g of x, so we have g of x here, right? So, but we're still using the PMF of x, right? So here, the idea is that we are still using the PMF of x, right? So we're still using the PMF of x to find the expected value of function of the random variable x, right? So what we're doing over here is we replace x by gx, but still working with PMF of x, right? So when you want to find the expected, when we want to find the expected value of a function of a random variable x, so we're going to replace x over here with gx, but we're still using the PMF of x. We don't need the PMF of that function for this, right? So based on this, we can say expected value of x squared. Now here g of x is just x squared. So I can write it as summation over all x squared pxx, right? Here what we've essentially done is we have just simply here gx is just equal to x squared, right? What if I wanted expected value of x cubed? Then this would be summation over all x cubed pxx, right? So here, gx is just x cubed, right? Right, and what if we wanted expected value of square root x? Right, so summation x pxx. So here gx is just under root x, right? So like we said, using the PMF of x, we cannot just find the expected value of x, but we can find the expected value of a function of the discrete random variable x. So now let's go back to the example we were doing and find the expected value. So let's actually find the expected value. So go back to previous example. This is example we did in the first part. We were looking at how to find expected value function of a discrete random variable. Go back to the previous example from part 1 of this. There we said we have this discrete random variable x which takes value 0, 1, 2, and 3. And we have its probabilities given to us as 1 by 8, 2 by 8, 3 by 8, 2 by 8. So now we want to find, first we learned how to find expected value of x. Now we want to learn how do we find expected value of x. So now we know, we know expected value of x square. We know expected value of x square, which is simply be summation over all x square, pxx, right? Gx is x square here. So I essentially want to sum up. So I want to sum over all x square, px. So what I'm going to do is I'm going to make this table over here. X takes value 0, 1, 2, 3. And then I have the probabilities given for each of these values. 1 by 8, 2 by 8, 3 by 8, and 2 by 8. Now I'm interested in x squared, so I'm going to take the square of each x value. 0 square is 0, 1 square is 1, 2 square is 2. Sorry, 2 square is 4, my bad. 3 square is 9. And then we see what x square into probability x is equal to x, right? Because what we want to do is we want to sum up over all x square plus x. So this is going to be just simply 0 into 1 by 8 is 0. 1 into 2 by 8 is 2 by 8. We're going to sum up all these values essentially. And then we have 3 by 8. So this is, 8. Let this look that clear. So we'll just do this a bit. This is 3 by 8 into 4 is 12 by 8. And this is finally 9 into 2 by 8 is 18 by 8, right? So now what we want to do is we just essentially want to sum up all of this because that's how we find expected value of x squared. Over all x, we just sum up x squared pxx, right? So when we sum up all these values, 0, 2 by 8, 12 by 8, 18 by 8. So we're going to get 18 plus 12 is, we know, 30. So it's going to be 32 by 8, which is 4. Right? So from here we know the expected value of x squared, which we saw is the summation over all x squared pxx is just 4, right? In this way we can find expected value of x squared just using the PMF. What's the point of this? Let's just quickly look at that. Now, what's the point we're trying to make here? What's the point, right? What's the point here? Right, the point is you don't need to know the PMF of g of x. You don't need to know to find its expected value. You don't need to know the PMF of this random variable gx, because remember function random variable is also a random variable. All you need is PMF of x, right? So we also obviously one way all you need is obviously one way to find the expected value. Like see, we know okay, this is so you know, remember function of a random variable is also a random variable. So remember function of a random variable is also a random variable, right? So we could say, okay, we could one way to find the expected value of this function random variable, which in itself is a random variable, is to use its PMF, but we don't need its PMF. To find its expected value, all we need is PMF, right? So using PMF of x, we can find expected value of not just x, but of any function of x as well, right?